Hey guys, welcome to 8.2 where we're going to be talking about conversion factors. In this video we're going to learn about one-step conversions, and next video we're going to learn about two-step conversions. So conversions are very similar to wrapping in the fact that well, actually they're not. They're nothing like wrapping. I'm just wearing a hat and mentioning wrapping to get you interested in the video. What do you need to know about a conversion factor? Well, a conversion factor is simply just an equation, okay, like this one that you see right here. It's just an equation that helps you get from one unit to another. So if we are in moles and we want to get to atoms or molecules, we can use this conversion factor to get us from one unit to another, okay? So conversion factors are equations. 1 mole equals 6.02 times 10 to the 23rd particles, okay? That's an equation. Well, we can set up equations like fractions. In fact, we have to set up our conversion factors as fractions so that we can use them in our T-chart method, okay? We can set up this conversion factor like so. 1 mole can be on the top of the fraction, and we can put 6.02 times 10 to the 23rd particles, which, by the way, particles just stands for atoms or molecules. We can also flip this fraction around the other way. In a moment, I'm going to explain to you which fraction you're going to be using, whether you'll use this one or whether you'll use this one. The most important thing is that this is a conversion factor that you're all expected to know and memorize. And then you'll have to know that you can either set it up this way or you can set it up this way. Okay. So now let's look at our second conversion factor, and we learned about this one in our video 8.1. So we learned that the molar mass in grams of an element will equal 1 mole. We call this the molar mass, okay? Where can we find molar mass? BT dubs. Where can we find the number for molar mass? Because notice there's no number here, right? Like in our other conversion factor we had the number 6.02. Well, here there's no number. So where do we find this number? Well, the number stands for molar mass, and we get it from the periodic table, right? You have to look on the periodic table and find that mass on the periodic table, and then that would be the number. So whatever the molar mass is of a certain element in grams, that will equal 1 mole of that same element. So like, for example, you could do 1.01 grams of hydrogen equals 1 mole of hydrogen. By the way, you can also abbreviate mole, M-O-L, and so they just took off the E. It's weird. Anyway, moving on. So we can either set it up, we can put the molar mass on the top, so number of grams can go on the top, and 1 mole can go on the bottom, or you can flip it and you can put 1 mole on the top or number of grams on the bottom. Okay, so now let's get to the heart of the issue. Here's an example problem, okay? It says in this reaction, one of the products you're going to form is a diatomic molecule, which, by the way, guys, diatomic molecules always have 2 atoms, right? And we know the diatomic molecules, they form a 7 on the periodic table, okay? It's everything in group 17, and then it's nitrogen, oxygen, and then fluorine and everything down. So it's like NOF down, okay? Also, little h over here is also not diatomic, just FYI. Okay, anyway, moving on. You measure the product and you find that you have 28 grams of N2, okay? That's your product. How many moles of this diatomic molecule do you have? So here's my 7 steps for doing conversions. If you follow these 7 steps, you won't get lost. If you try to do it your own way, there's no guarantee where you might end up. First thing we do is we identify the given, and then we're going to identify our final unit. Well, what number are we given? In this equation, we're only given one number, that's 28 grams. So I'm highlighting it, okay, and I'm paying attention to it. Your given's really important. What's our final unit? Or in other words, what are we looking for? What are we trying to convert to? It's asking us how many moles. So moles is our final unit. So I always start, when I set up my T-chart, by the way, we've done number 1. Yay! Give yourself a little pat on the back. Great job. You've survived thus far. And step 2 asks us just to set up our T-chart. So the T-chart, when you're setting it up, you always put a line that as your first fraction, and you're going to put your given over 1. So I'm going to put that in parentheses here. Always put your given over 1. That's your starting point. That's always your first fraction. So what's our given? Well, we said that 28 grams was our given, right? So 28 grams goes on the top right here. 28 grams. Now, I have my unit, but I also need to add something after my unit. So I'm going to be the teacher that is super particular and snarky about units. If you just wrote the number 28 there, I will find you, because you have to add your grams on the end, and you also have to add your identifier at the end. The identifier is like 28 grams of what? What do we have 28 grams of? Do we have 28 grams of marshmallows? Do we have 28 grams of pretzels? Do we have 28 grams of chocolate chips? Obviously, I'm hungry from the examples I'm using. So what do we have 28 grams of? Well, we have 28 grams of N2, okay, this diatomic molecule. So I'm going to write 28 grams of N2. Later on, not necessarily in this unit, but later on when we get to stoichiometry, the identifier is going to be very, very important. Identifier. So I'm going to teach you and train you now to add the identifier after your unit. So you have 28 grams of N2, and what goes on the bottom? Always 1. Your first fraction always has 1 on the bottom, remember, from right here. Given over 1. Then I'm going to put my multiplication sign. I'm going to add my conversion factors. Your conversion factors, remember I said you can set up your conversion factors as fractions from up at the top? Well, we're going to find which fraction we need, and we're just going to plug it in right after this, right after our given. Okay, so we've done number 1, we've done number 2. Give yourself a little pat on the back. Congratulations. Okay, number 3 asks us to find the conversion factors. I always write out my line of thinking. So I'm in grams right now, okay? But I need to go to what? What am I going to? I'm going to moles. That's my final unit. Grams to moles. This is my thought pattern. If I write out my thought pattern, it helps me know which conversion factor I need. I'm in grams. I'm going to moles. That means I need a conversion factor that has grams and has moles. Let's look up here. Looking at just these, hold on. Looking at just these two conversions. So here's the first one. Here's the second one. Which one of these do we need to go from grams to moles? Well, this one has moles in it, but it does not have grams. It has atoms and molecules as the other part of the equation. This one has moles and it has grams. So that means I'm going to be using this conversion factor. So now my next question is, well, how do I set up my conversion factor? Do I set it up this first way, or do I set it up this second way? Okay, I have two options. I can put grams on top and moles on the bottom, or I can put moles on top and grams on the bottom. So I'm going to kind of scroll down here so you can look here. Grams is on top on this first fraction. Whenever you set up your next fraction, guess what unit has to be on the bottom? It's got to be the same unit that was on the top on the previous fraction. That means grams of N2 has to go down here. Now, why do we know that? Well, if I'm trying to get from grams to another unit, I need to cancel out of my previous unit. So I want to cancel out of grams of nitrogen. The only way I can algebraically cancel out of a unit is if one unit's on top and the same exact unit's on the bottom, so I can cancel them out. So that means I want to orient it this way. I want moles on top. I want grams on bottom. So I take the 1 mole, and that goes on the top. I'm literally copy pasting this fraction into my conversion. Number of grams goes on the bottom. Well, how do I find my number of grams? Well, remember I mentioned that what this number stands for? This is your molar mass. Molar mass. Okay, so this is not just nitrogen though. I can't just look on the periodic table and find the molar mass for nitrogen. It's in 2. So I have to find the molar mass for nitrogen 2. So if I go all the way on the periodic table, nitrogen's molar mass is 14.0067. And remember how I kind of always round to the hundredths, so it'll be 14.01. So 1 nitrogen is 14.01. But how many nitrogens do I have? I have 2 nitrogens. So The molar mass of N2 is going to be 2 times 14.01. I'm sorry, it's not 0.01, it's 0.1. Silly me. Okay. So that comes out to 28.02 grams per mole. That's the molar mass of N2. So this number is going to go in right here. Okay, so now that I've done this, I can cancel out units. Okay, so we found the conversion factors. Arrange the conversion factors so that you can cancel out your units is the fourth. So now that we've done step 3, step 4 asks us to arrange the conversion factors so that our units are canceled out. And we kind of already did that. I arranged my conversion factor with grams of N2 on the bottom and moles on top. The reason I did that was so that my grams of N2 and my grams of N2 can cancel out. Now you have to make sure that in order to be done, that you're left in the unit that you want. What unit did we want? We wanted moles of N2. I have to write my identifier. So now we're in moles of N2, and so we're happy. We're good to go, right? If that's our final unit on the very top of the last fraction, then you are good. So how do I solve this now? Well, that leads us to step 5. Step 5 asks us to multiply the top. Step 6 asks us to multiply the bottom, and then step 7 is to divide the fraction. So first, let's multiply everything on top. So that's 28 times 1, which is just 28. Now, it's not 28 nothing. What's our unit and what's our identifier? Well, grams of N2 have been canceled out, so the only thing we're left with is moles of N2. Step 6 asks us to multiply the bottom. So we multiply 1 times 28.02, and it gives me 28.02. My last step is to just divide this fraction, okay? So I have 28 moles of N2 divided by 28.02, and my answer, when I divide it, is 0.999, and usually I round to the thousandth, so this would really just turn out to be 1.00. What's my unit? Moles of N2. So I have 1 mole of N2 when I started with 28 grams of N2. Okay, so let's do a couple practice problems. Okay, I'm going to do this first one with you, and the last 3 are really just practice problems. I will have, I'll do probably one of these on the board with you guys when we get back to class. So first, we start off with this is our given, and we're looking to go to moles. Okay, so we're starting in molecules, and we're going to moles. That's our thought pattern. Okay, so I always write off my given as over 1, so it's 6.92 times 10 to the 25th molecules of barium nitrate. So I have to write out barium nitrate. Barium is Ba, nitrate is NO3 with a -1 charge. Barium is in group 2, so its charge is +2, so our formula is BaNO3 2. So I have this many molecules of BaNO3 2, and you actually have to write all of that out when you're doing the problem, and it's always over 1. So what's my next fraction going to be? Well, I'm going from molecules to moles, so what conversion factor can get me from particles or molecules into moles? Well, we know that 6.02 times 10 to the 23rd atoms, it's supposed to be third, atoms or molecules will equal 1 mole. So that's the conversion factor we want. So which way are we going to set this up? Well, I know I have molecules up here. So that means I want molecules of BaNO3 down on the bottom left so that I can, on the bottom right, I'm sorry, so that I can cancel them out. So molecules and molecules can cancel out. I have to put this number here because that's the number that goes with molecules on my equation. It's always 6.02 times 10 to the 23rd molecules, so that has to go on the bottom. 1 mole is left over, so that's going to go on the top. So since molecules have canceled out, I'm left with moles, which is what my final unit was in, so I'm good. Now all I have to do is multiply, multiply, and divide. So if I'm doing this, I can see if I multiply this number times 1, I end up with 6.92 times 10 to the 25th. And then 1 times this number is 6.02 times 10 to the 23rd. I get 114.95. Now what's my unit? Well, I'm in moles of barium nitrate, so I put moles. Okay, go ahead and practice out the last three on your own, and then we'll go over one or two of them in class. Have a fantastic day and stay fly.